Welcome to the second part of the Haber process video. In the first video we looked at the process itself, we looked at the conditions that are used, why we want to make ammonia, what ammonia is used for, and in this video we will look at why we choose the particular conditions. So I'm going to scroll forward. So, in an exam you might be asked to justify the conditions which are used in the Haber process, and we went through which conditions were actually used in the last video. We use 450 degrees C and 200 atmospheres, and you can see that if you use this rather nifty graph, that these conditions give just over 25% yield of ammonia. So what you're expected to do is comment on why we use 450. And to do that, I think it's sometimes easier to justify why we don't use a lower temperature and why we don't use a higher temperature. Similarly for pressure, why we don't use a higher pressure and why we don't use a lower pressure. So I'll go through the temperature first. And this graph shows very nicely the effect of lowering the temperature. Lowering the temperature actually gives a high yield of ammonia. And you'd expect that because the forwards reaction is exothermic, so if you lower the temperature, the equilibrium shifts in the direction of the exothermic reaction, which is to the right. So if a lower temperature gives a higher yield of ammonia, why do we not use a lower temperature? And the reason for that is that at a lower temperature, the reaction is too slow. It might produce more ammonia, but you have to wait a very, very long time for it to get to that equilibrium point where you produce that maximum yield. So at 350 degrees C, the reaction is too slow. So we heat it up. We don't go as far as 550 because look how low the yield is then. The yield is only about 12%. So at 550, the yield is too low. So we choose a compromise temperature of 450 degrees C. We compromise on 450 degrees C. Again, we have to compromise with our pressure. At 400 atmospheres, look at what that does to the yield of ammonia. Even at 450 degrees C, you're producing over 40% of the ammonia. Well, you're producing a yield of 40%. So why do we not use 400 atmospheres pressure? Because that gives quite a lot of ammonia. And the reason for that is at 400 atmospheres, the reaction, that kind of pressure is actually very dangerous. It will be expensive and it would require a huge amount of kit to contain that kind of pressure. So therefore become expensive. So we don't do it at that temperature because it's dangerous and expensive. We don't use a lower pressure because look at what that does to the yield. Okay, if we drop the pressure down, it drops the yield. So too low yield. And you would expect that to happen. If you remember back to your Le Chatelier's principle, if you lower the pressure, the equilibrium position shifts to the side of the reaction with more gaseous molecules. And in this reaction, that's the left-hand side. On the left-hand side, we have 4 molecules. On the right-hand side, we have 2. So, if we lower the pressure, it shifts, in this case, to the side of the left because that has the more gaseous molecules. So, 200 degrees C is, 200 atmospheres is a compromise pressure. You might also be asked to justify why an iron catalyst is used. Well, a catalyst has no effect on the yield, and it's important that you point that out. So catalyst, no effect on yield, okay, but it does increase the rate of reaction significantly. And that concludes our look at the Haber process. In the next video, we will look at the contact process, in other words, how we make sulfuric acid industrially.